I'm going to talk about something that I've come across at Thomson Reuters with my team. And this is the sort of clickbaity headline that I came up with. And that's solving what I think is a new kind of problem in data. And basically, I think that this is a really exciting time to be working in the space that we are working in right now, or aspiring to work in, or learning to work in. So let's start off with a joke. And it's actually a joke that I learned while I was taking math at U of T. So it's really much more of a riddle. And it goes something like this. You walk into a room, and many of you have probably already heard this, but you walk into a room and you see a jug of water on a table. And on the floor, there's a bucket. And the question here is, how do you get the water from the jug into the bucket? And, you're a human, so of course you can just figure this out. You don't need to be trained on this or anything. You just take the jug, you pick it up, you pour it into the bucket. But there's a catch. There's a second part. You walk into a room and you see a jug of water on a table. And you also see a bucket. And this time the bucket is on a table. And the question is, how do you get the water from the jug into the bucket? So of course you're a human and you pick up the jug and you pour it into the bucket. But that is the wrong answer. That is not what you're supposed to do if you are a mathematician or a computer scientist. The right answer is you put the bucket onto the floor and you reduce it to a problem that you've already solved. So this is a great joke, or a great riddle, or I think it is, because it illustrates something. And that is, you shouldn't solve the same problem twice. You should lean on the existing solutions. Lean on something you've already done. And in coding paradigms, in math, and other kinds of cultures, let's say in the tech industry, we see that this is a very important tool. Don't try to reinvent the wheel. Use what you already know. But I sometimes wonder if this makes us a little bit myopic, or gives us a bit of tunnel vision as to where the world is going, because we know that the industry changes, that new problems come about. Where the industry was 50 years ago is very different than what it is right now. And we have whole new tool sets available to us. So let's talk about some high-level problems and high-level solutions, just to get a feel for it. I don't think that this is going to be anything new to anyone. Methods eventually got too complex, so we came up with algorithms. Eventually, we had computational complexity. So we actually invented computers, and on those computers, we had to do programming. Code complexity was handled by coding paradigms. We had OO, we had functional, we had imperative before. Project complexity was handled by project management, and data complexity was handled by a field today called data engineering. But there are things to keep in mind as we remember all those. One, they are human constructs, and two, they're constantly evolving. They're not something that just stays still. And those 2 points might seem really obvious, but I find in everyday conversation or an everyday debate, it seems that we forget about them. So what do I mean by their human constructs? Well, consider things like merge sort versus quick sort, or OO versus functional, MVC versus MVV, agile versus waterfall, so on and so on. The problems don't care about what you just did there. They don't care about the fact that it's a merge sort versus a quick sort, or it's an OO versus a functional. And yet in our everyday vocabulary, we still describe problems as OO problems or functional problems, or an MVC problem versus an MVV problem. We'll still describe problems by the framework that we use to solve them. Now, what do I mean by still evolving? And I just talked about like the functional OO debate. And that I think is kind of what I'm talking about there, but it's not what I'm going to talk about. But it is sort of, both of these things came about to handle code complexity, but there's a debate as to which one handles it better. Let's instead consider microservices versus monolith. In the history of how these things came about, the monolith came up first, but it wasn't called a monolith because it was the only thing that existed. Microservices, first as a service-oriented architecture, was proposed as a way to handle larger systems. But the problem was that teams who kind of leaned between SOA and microservices caused more problems than solutions. They didn't know how to handle those things. So the monolith sort of made a quick comeback. And for small projects, people started to debate as to whether you should build microservices first or build a monolith first, and then worry about transitioning to microservices when you hit scale. Then, of course, that created all sorts of other debates that came out of it. That is, should you start this way? Should you start that way? What even makes a microservice a microservices? How small should it be? And how you define size when it comes to that. So I've actually talked to people in the industry where they don't even think this is a debate. They think that, you go microservices all the way and no one is actually debating these things. But if you think they're not debating these things, then you're just not paying attention to what's going on in the industry. Everything is actually still up for debate when you look at it at a low enough level. So when you take these two kind of components, the fact that they're a human construct and they're still being debated, that is, that we've just come up with these arbitrary categories and we don't even really know how things fit. Maybe they fit in one, maybe they fit in the other, maybe they fit in both, maybe they fit in neither. The inescapable conclusion is that there must be sets of problems that defy categorization or methodologies for our solutions. We're sort of just shoving them in a box where they don't actually belong. But they don't necessarily belong in that. And the actual tool set that we really need is going to come somewhere in the future, or is being invented right now, or developed, I should say. And the interesting thing is that you've likely worked on some of these problems that defy that categorization, that aren't really a great example of OO and really work better as in functional, or neither functional or OO and work better in something else. So do we have examples of those problems that defy categorization? Well, this isn't a great example, I don't think, but it's a question that I try to put out there. That is, can a problem be both relational and non-relational? And I think that, the smart people in the audience are probably saying immediately, well, obviously not. Those things are mutually exclusive, right? There's no way. There's no intersection between relational and non-relational. The words are completely different in that way. But when you think of how the industry has evolved and how the language has evolved around that, we actually have more words to describe that. We have relational, we have SQL, NoSQL, and non-relational. And if we look at what's happening in this space, we have NoSQL databases that are doing relations. We have SQL databases that are having non-relational type nested categories such as JSON-B, and everything in between. So when you have something like a Postgres that is having nested type data inside of it, and you have something like a MongoDB that is handling relations and transactions, you have to start asking, is there a problem that sits right in between those? That when these things were first conceived as standalone solutions to handle completely different kinds of problems, is there one that was sort of born somewhere in the middle, that's fallen on the border, that's pulling both of these kinds of technologies toward the middle? Another one, this was sort of like a joke that I put in here, but I sometimes ask, does anybody ever really do Agile? Because I think it's a sort of no true Scotsman fallacy. I often hear criticisms of teams saying, we don't actually do Agile. We actually just take an implementation of Scrum, or we're actually waterfall. We're not really Agile. And it's a criticism that I hear lots and lots of places. So maybe Agile, when it was written up, in the early 2000s as the Agile Manifesto, was written as this ideal, as a bunch of criteria that we should strive toward, and no one has ever hit it. Or we're actually just all committing a no true Scotsman fallacy. I'm not sure, but maybe there is actually something, and I've read blog posts about this, that is sort of in a post-Agile world that is going to be the next method of project management and sort of software development that is better than what Agile is today, or what Scrum is today. Now, I want to talk about what the problem is that I'm interested in, and I've sort of already hinted at it. And it's not the relational, non-relational one. It's actually, I think, a little bit easier to describe, and that is, can a problem be both analytical and transactional? Another way of describing that is there a problem that is both OLTP and OLAP? So some of you may have, probably many of you already can describe what OLTP is and OLAP is. The interesting thing about those two kind of categories is I find that in this work, people almost instinctively know what it is, but they can't describe it when asked. So it's one of those things where someone says, well, define like an article, like the, and you have trouble defining it, but you use it all the time. So we kind of know what the problems are, but we haven't defined them very strictly. So I basically plagiarized them from this site called Tech Differences. And I think they did a pretty good job of how they did that. Now, of how they sort of outlined the differences between the OLTP and the OLAP type problems. So at a high level, what you want to think of is that OLTP focuses on modification of records. That is, individual records are constantly changing, whereas the OLAP type problems have to do with reading massive amounts of those records. And unlike the wording that I chose before, the sort of relational, non-relational type problems, you might notice that the OLTP and the OLAP aren't actually mutually exclusive. That is, someone who really cares about modifying records might also really care about reading and analyzing those records. So there's nothing that explicitly excludes one type of sort of solution, an OLTP solution, from being an OLAP solution, other than the fact that they're not today. So what do I do again? Why do I care about this? Well, my team cares about ingesting data to process it and use it for all parts of the tax department, so the tax department can calculate and report on tax. I know a lot of people don't know that Thomson Reuters actually works in tax, right? We work in tax and media and law. So my team, we're on the corporate side, and we care about ingesting data and making it available to the tax department. When I joined Thomson Reuters, a former boss of mine emailed me and he said, "Hey, I hear that you have just inherited the world's most complicated CSV importer." And he wasn't completely wrong, because at a high level, what we are ingesting is tabular data that we just want to make available to a whole bunch of different tax departments. So why is that even complicated? Why are we even sort of getting in a huff about this? And a lot of people don't have familiarity with how it works, but the closest analogy that I can think of is that imagine that you are all employed people. You know that you have to pay income tax, but at the same time you have to pay sales tax, and you also have to sometimes pay property tax. And of all of those taxes that you have to pay, the government will expect some kind of a payment on that, and know that the payment that they're getting is correct. Corporations have to do the exact same thing. And for them, in order to make sure that it's correct, they would like to be using the same subset of data. So whether they're paying sales tax or property tax or income tax or any other kinds of the hundreds of kinds of tax there are out there, they want to make sure that they're using the same kind of data. Because if they report some kind of an asset as some number on property tax and is different on their income tax, that causes a problem. So that's the challenge that we're trying to accomplish. So when we go back to this sort of chart and we ask ourselves, well, what are we actually trying to solve here? Is it an OLTP problem or an OLAP type problem? Well, when we go through this system and let's say we present it to our product team and we say, hey, do we have records that we need to modify? And we ask them like these kinds of questions, and they'll say, yeah, we definitely, we want that, we want that. We want that. We kind of want that one too. Yeah, simple for sure. We want that one. We want denormalized stuff. Yeah. But then when we look at the other side, we're going to say, yeah, well, we want that one. We kind of want all of these. Yeah. And we want complex queries for sure. No question about that. Yeah, we want both normalized and denormalized data. That's absolutely. And, it sounds like I'm being facetious here. And you might say, well, congratulations, Peter. You found the product manager that actually wants everything, which is probably every product manager. But we should be asking, is this a reasonable thing to want? Should they actually want transactional style problems to be handled by analytical style solutions and vice versa? Is it a crazy thing to be asking for? And a lot of people might say right off the bat, yes, it is. Another class of person might say, you're making a mistake. This isn't really a transactional problem, or it's not really an analytical problem. And I think I'll get to that a little bit later. So let's just talk about the solutions that we have. So the first thing that I want to say is kind of what I already alluded to, is you pick a lane and you manage expectations. This is sort of the sad path that you can take, but it's not, I shouldn't downplay it. This is something that is important, and we don't always do a lot of it. So we need to recognize that they're not asking for everything. What they're actually asking for is a solution that has transactional components and it has analytical components. And what we really need to do is build two different solutions. So we divide the problem, solve them one at a time. Now, there are drawbacks to doing that. One of them is that you have to be able to separate those components very, very early on. And it might seem like that's a very easy thing to do, but it sometimes happens that you have a miscommunication in how the problem is described to you, in the size of the data. I sometimes joke that, big data means something different to everyone. Sometimes it means that Excel will break, and other times it means petabyte scale data warehouses. And a customer will use both sometimes. So miscommunications happen. Absolutely, you should get ahead of it. You shouldn't start building until all of those miscommunications have been handled, but they do happen. And if that miscommunication is causing a choice when it comes to your backend database between OLTP and OLAP, you might be in big trouble. So you do need to be careful about when you make that separation. A lot of us don't even have to think about this, because if you're, let's say, already a data engineer or you're a data scientist, you've already been hired into a class of problems that have been labeled OLAP. You don't have to think about what if this is actually a transactional problem, because you will be handed analytical style problems. So if you go this route, the unfortunate truth is that your user or your product manager will have to recognize that there is a need to split those solutions. You'll have to sell them on the fact that you need to build two things here. They can't both be handled by one thing. And that takes a certain level of understanding that not everyone has. Because sometimes they'll say, I don't know why I can't put a very big, let's say, Excel document through the same thing that you're doing a database dump in or something like that. And it takes a certain amount of knowledge and takes a certain amount of managing expectations in order to be able to people to accept that solution. So Lambda architecture, I think a lot of people probably would have heard of this. You separate your solution into operational, real-time, near-time, and batch solutions. And I kind of put in brackets, that's an extension of Lambda, because most of the time people consider the operational and real-time the same thing. But the reason that I've separated them is because Lambda architecture does, in essence, one thing, and that is you have operational data, you have your batch data, and in the middle, you have everything in between. And there's no reason why, once you have your event-driven, near real-time data streaming through for a near real-time, let's say, recommendation engine or a context-based recommendation engine, a product manager can't come back and say, you know what, can we have another pipeline that's slightly faster than that one? And you might say that's unreasonable, but there's no reason why you can't have multiple pipelines running in parallel. It obviously increases the complexity of your project, but I wanted to highlight the fact that if you can do near real time, you can ask for things that are slightly faster, or you can say, can we get that enriched a little bit more, get more data, and have something a little bit slower than what you consider currently near real time. So examples of this, you can look to companies like Google and Netflix that do something like this. Google does that where they have, search is fast, extremely fast, but their web crawlers are slow. If you've ever put a website onto Google, you can see that it takes days for them to get to you. But they still have live updates from sites like the New York Times or Forbes or basically news sites that are up within minutes. So that is their kind of Lambda architecture, where they have their batch process running in the background with their web crawlers. Their search is extremely fast and responsive. So that's their operational data that is interfacing with their users immediately. But in between there, they have live updates. So they have a special system that is trying to keep sort of in between that batch process and the very fast search process. Another example, like I said, was Netflix. The app is very quick and very snappy, sub 500 millisecond type responses. but the collaborative filtering is a sort of complex algorithm that's running in the background. So that has to be done in batch. But that doesn't mean that Netflix can't do some smart things in real time. So while the collaborative filtering algorithm needs to be retrained using batch in near sort of real time, you can still do things like, what is it that you just searched for? What can I recommend based on that last search? And how can I update that? That doesn't need to retrain a model, but it does mean that we can provide a little bit of context to what the user is doing right now that makes your search results seem a little bit smarter. So the downside of this is that you are now running multiple pipelines. You're running multiple pipelines, and a lot of the time it means that you have completely different skill sets that are working in parallel. So your architecture is starting to get complex. And a lot of the time, I don't necessarily say you have to do this, but because the skill sets a lot of the time between your operational type data, your near time data, and your batch data are different, a lot of the time you'll find you need to have a team with strong contracts between teams to maintain each solution. So the last one that I want to talk about is the multi-pipeline method. I don't think this is just my word for it. But it's similar to the Lambda architecture, but you're only focused on the analytical style side of that problem. It's also similar to, I would say, the managing expectations side of it, where you have two different styles of solution. But what you're doing is you're abstracting the fact that there are two solutions away from the user or away from your customers. So you have a separate pipeline to speed up the low complexity type operations and a more robust pipeline, or let's say a more batch-like pipeline for the bigger operations. So you can think of, let's say, BigQuery and Snowflake, which are sort of managed data warehouses. They're using things like this in the background. So if you compare a BigQuery or a Snowflake to more traditional type data warehouses, with a more traditional type OLAP system, and you were, let's say, to throw small amounts of record at it, that system just can't handle it. But a BigQuery and a Snowflake can still handle that and figure out how to handle small queries alongside those larger queries. As I'm not sure how well known this is, but supposedly Google has spun up a team called Small Query just to handle that exact one problem. So the downside of this is that you can't have that sort of 500 millisecond response time for many of your operations unless you're running a transactional or a relational database alongside it for things like your metadata. But for many operations, that sort of app-like responsiveness is just not going to happen. Sometimes they might advertise that you can, but in practice, it just doesn't work, because what you're doing is you are using a data warehouse that can handle small workloads, let's say lots of parallel workloads, very well, but it'll never act like a sort of MySQL or anything like that. So let's handle some objections to what I'm talking about here. I told you at the beginning that this is a new style of problem, but really it's just an analytical style problem with transactional components. And I would say, like, yeah, that's absolutely true, but you're working under the assumption that you've already identified the transactional and analytical parts. And that's not always as obvious as it might seem. Again, if you work in, like, very specifically, if you work in something like data science, that work has to some extent already been done for you. That is, the operational data has already been extracted for you, or you've been told to ETL that data from somewhere else. So you don't actually have to think about what is the analytical part or what is the transactional part of this problem. You work under the assumption that it's an analytical problem. You don't have to do that separation. And if you do try to handle sort of transactional components with conventional OLAP solutions, it doesn't give a great user experience. You have problems like spin up times or 30-second delays and things like that. And the user just does not like that solution. And you end up having to go back and re-architect or create another pipeline or re-estimate right from the beginning. So yeah, I agree with you. It is an analytical problem with transactional components or vice versa. But I think that's an oversimplification for these two reasons. Another way of saying it is like, these aren't actually new problems because they can be solved with the current tools that we already have. And again, I would say, yeah, I absolutely agree with you. But an analogous kind of objection would be to say, well, code complexity was always a problem. It's not a new problem. Why did we ever start to use something like OO to handle code complexity? Or why did we ever actually start to use Agile when Waterfall could have still developed like workable software, and it did develop workable software? My thing, or my proposal, isn't that these are completely new problems, but they're a new class of problem where customers are starting to demand a more seamless transition between their operational data and their analytical data. And what their expectation is that there is actually no difference between those two things. That is, if they make a change to their operational data, they want to be able to run some kind of analytics on it immediately. And that is an interesting and sort of scary space to live in. And like we've already talked about how to handle some of those things, but there are drawbacks to each one of those. So let's talk about some of the solutions. And I'm just going to go very high level and quickly over here. And I think it's going to be a little bit ugly, but that's fine. So we create, I don't know what it's called. It's not mine. This is plagiarized from someone else, some other data engineer, but what I call an OLAP pipeline. So we identify the problem that has an analytical component to it. So that means like it requires some ML recommendations, etc. If it has no analytical component to it, then you use some kind of a transactional solution. So it doesn't use the same kind of framework. You're going to use some ORM type solution. So you divide the analytical part into the following steps. You think about how the data is going to be ingested. So how are you importing your data? Is it done through some web interface? Is it through a direct database connection? Are you streaming data in from somewhere? Next, where is the raw data stored? This is almost always some blob store S3 type solution if you're working online. And you want to keep that raw data. You never want to go back to the raw data. So the raw data always should be as raw as possible. So the next step is you're going to want to process that data. Just as a sort of side note, a lot of the time, this is right now described as ELT instead of ETL. So that is, you extract it and you load it first, and you figure out how to transform it after the fact. So you can think of like the processing here as that kind of transformation. So the question here is, how do you want to process that raw data to make it more usable? Sometimes there's denormalization in there, there's enrichment, there's transformations, there you have to bring in other data sets, that kind of thing. And of course, if you bring in those other data sets, you're going to ask the same questions around it. So now you're going to curate that data. So that at this point, you're going to want to store the process data in another form. You can actually put that back into your blob store if you want. There are technologies that allow you to query it directly out of there. You could also put it in some kind of a transactional database at that point if you want really fast query speeds, or you want to put it in some NoSQL database like Redis if you want something that's blazing fast but maybe doesn't have the same kind of, let's say, wide columns or the flexibility that you had before. Then you're going to provision it. So do you want to allow the user to connect directly to your database? You want them to have a BI tool that gets to it? Do you have an API layer, something like that? So determine a solution for each of those stages. So what technologies are you using? And it's interesting that on this side, when you're talking at this level, a lot of the time, the conversation has to do with infrastructure. It doesn't have to do with what your code looks like, even though that's going to be an important part. But it's a lot about stitching together infrastructure, because you don't necessarily just want to be using, let's say, Docker running on ECS to handle all of these things, because someone has made a better managed solution for you already. So does the solution meet the requirements once you, let's say, stitch all those things together? And a lot of the time you'll get there and you'll say, no, it doesn't meet it. And in my experience, usually the answer is it's too slow to run through all of those steps. So at that point, you go back to number 3, you determine a solution for each stage. And you check if there are better technologies, better solutions that you need to stitch together. If that doesn't work, then what you have to do is you have to split this pipeline into two. That is, you have a pipeline that handles things faster and a pipeline that handles things slower but more thoroughly. And the two of them now work in concert. So you have one pipeline that handles, let's say, the 500 millisecond response type problem, and another pipeline that handles the rest of your data. So in my work, what we've done is we were trying to ingest lots of tax data, and we wanted to get them working as quickly as possible. But sometimes this tax data had billions of rows. So we didn't want to wait for the ingest to complete before they started to work on it. So instead, we had two pipelines, one that took essentially the top of the tax data as it was being uploaded, and the rest that would handle the tax data in batch to prepare it for use down the line. So in order to do that, we started to look at things like this. We were looking at Amazon EMR to do some extracts from a database that would throw it into S3. Then we had another EMR that would transform it and throw it into a Redshift. And then we had an API layer that would extract it or allow the users to extract it and put it into some kind of a BI layer for themselves. This is just sort of a sample for a different kind of problem that we had, but it still ran into a lot of the same kinds of issues. So we kind of re-architected it in Google Cloud. And for those of you who are familiar with Google Cloud, you know that this is basically a mirror of the solution I just showed you. But because Dataproc can run PySpark or Spark just like EMR can, but they also have an alternative in Dataflow, where you can do something that's a little bit different. Cloud storage is exactly like S3. Then we did the same thing again, where we used another EMR-like solution. And instead of Redshift, we would throw it into BigQuery. This solution, although more scalable, was not actually any faster because it still had to run through the whole data pipeline. So we took a look at this and we said, well, can we make this a little bit faster? And we used Dataflow streaming, and Dataflow streaming would throw it into cloud storage, but at the same time, do some things in Spanner and in Bigtable that allowed the user to get immediate results. And we had to choose between these three technologies down here as to where we could manage expectations. BigQuery gave us the most scale, but didn't handle, let's say, the sub 500 millisecond response times, which no one ever asked for, but it's always a nice thing when you're building an app to have that. Spanner was very expensive, but did handle all of the needs that we had. And Bigtable was essentially like a giant Redis. So it was fast, and it was cheaper than Spanner was, but didn't have the scale of BigQuery. And then we had an API layer just like before. So we recognized is we have these two data pipelines, one that was fast enough, the other one that was robust enough, and we had to revisit the first one and combine the two. So we now have, let's say, some streaming technologies up front, and we're also doing periodic database dumps. We're combining those things together using either Dataproc or Dataflow, throwing them into a BigQuery, and then making them available through the API. What our customers get out of it is that they now essentially have a petabyte scale data warehouse at their disposal. And because we're using things that are essentially like serverless, they have practically infinite scale, and we can pass on the cost to them. So they're paying essentially S3 for their storage. They have terabyte scale or more queries to perform their bulk operations, but they also have streaming for fast operations, which is like, I say Twitter scale, but it's Twitter-like. I'm probably giving myself too much of a compliment there. So that's what I was talking about, that a user can start to work on a stream of data immediately while there are bulk operations happening in the background. And they also have, because we have databases that are managing the metadata, and we use things like GraphQL, we have transactional-like app qualities for the interface. So it still feels snappy and it feels like a modern app, even with all of those things happening in the background. So let's move on to what the conclusion is. So is it worth maintaining that for the ultimate solution today? It's you have to sort of maintain, I'd say, or set expectations. That is, when somebody comes to you with a problem where it sort of falls on the cusp of both being transactional and analytical, you need to be able to say that you're essentially, your team size can sometimes double in order to maintain both of these things. And the cost of that is sometimes just not worth it. But you can manage a lot of that by leaning on managed services over open source. So open source, let's say 8 years ago was all the rage. And I don't want to put down those open source projects because they inspired what exists today. But today, I think the complexity of the solutions is getting higher and higher, and we need to be able to lean on what already exists in the industry and not reinvent that wheel. And that's where the jug of water and the bucket, I think, is a reminder of still what we need to be doing, despite the fact that I do believe that we're heading toward a new class of problem. There are still places where we don't have to repeat ourselves. We don't have to look to new solutions, because I believe that a lot of people have already figured out a lot of the heavy lifting. And there's still a lot of interesting problems in the higher level to figure out. And I think that in the future, we are going to see a lot more transactional demands on analytical data. And I've already mentioned this once before, but we will see customers coming to us saying, I want to see reporting, or I want to be able to make ML style decisions about what I'm going to do next. Like I want my model to be retrained every second. And I know that that's going to be a silly thing to say for right now, but that's going to be the mindset of a user in not that long. They're going to want to see results as soon as they make a change. And we're going to have to handle that through basically parallel data pipelines that run at various speeds and can give different kind of results.